So last time we were stuck at FTP port. Okay, right. So let's discuss that again. FTP protocol. So so basically FTP operates on two port numbers that are 20 for data channel and 21 for the command channel, which is 20 for the file transfer and 21 for the command channel. That is clear, right? So basically FTP is used to transfer the file. And in FTP, we have two types of ports, basically two types of modes that are active, and second one is passive. Okay. So basically, in active mode, the client initiates a control connection. Okay. And the server initiates the data connection. Okay. With the client. But in passive mode, the client is the one who only initiates both control and data connection. The server. And that is the major difference in the active and passive mode. For example, here, look at this image in the active and passive mode. So in the active mode, suppose FTP client here connects via any random port. Let's say any random like 1224 port. Okay, so the FTP client sends the connection request on port number 21 because 21 port is used for connection making. Okay, that is for the connection command channel. Okay, so here the FTP port sends the connection request on port number 21 to the FTP server. Then FTP server and the connection has been established. After the connection, when it comes to data transfer, then the FTP server itself sends the port request to connect. Okay, or for making the like data channel or data connection to the client. So here the port FTP server at port number 20 transfer or send the data or sends the connection or request to the FTP client. Okay, so here FTP server, like the source port of the FTP server is 20 and the destination port can be random. Okay, that is in case of active mode. Okay, now in terms of passive mode, here the FTP clients only sends the command and data connection to the server. Okay, from here FTP client here there's a random port. Okay, and via random port the FTP client sends the request on port number 21. After the connection has been established, then the FTP client is the one who only sends the data connection port on random port, not on port number 20. Okay, so that is passive mode because here the FTP client itself sending the port number to connect to the FTP server. Okay, let's say here, let's take an example. In the active mode, let's say this is my FTP client and this is my FTP server. So in this case, my FTP client is sending the request to FTP server on port number. Let's say FTP client chooses any random port. Okay, to connect on port number 21, which is the FTP like connection oriented, like connection making port. And second, the FTP server sends me the request for the data transfer. Okay, on port number 20, from port number 20 to any random port, which is again 1224. Okay, or any other port number. That might depends. Okay, so this is in case of active mode, where the FTP client is sending first the connection request on from random port to port number 21. Okay, which is like the FTP 21 port for connection making. And then the FTP server is initiating the data channel from port number 20 to any random port. Okay, that is active mode. And in case of passive mode, here the FTP client, FTP server. And here FTP. So basically here, let's say the client connects on port number from port number 1224 to port number 21. Okay, this is for the simple connection making. So here, as you can see, we're sending the request. And here in the FTP client, in this passive mode, the FTP client initiates the data channel also from any random port to any random port. Okay, let's say it chooses any random port, uh, 1334. And FTP server also chooses any random port for the connection. Okay, so instead of connecting on port number 20, FTP server is also choosing any random port. That is in case of passive mode. Okay, so this one is active and this one is passive. So in this passive mode, that FTP client is sending the command request as well as the data channel request to the server to connect to. Now in case of firewall, okay. So suppose here, let's say there's a FTP client. So this one is a passive mode only. Okay. So this FTP client, and here let's say there's a FTP server. And let's say there's a firewall here. Okay. So here FTP client. Here we can see there's a firewall. And here again FTP server. Now the scenario is same. Okay. Here my FTP client sends the connection request, and same as my FTP client sends the channel request. Okay, that a data channel request, and then FTP client connects with any random port. So this is in case of FTP, like a passive mode with firewall. Let me name it passive mode firewall. So here, let's say the client connects with any random port to port number 21. Okay. So first the client sends the request and then server sends sends the connection back. That is here the connection has been oriented. Okay, established up to here. Then after that, in the passive mode, the FTP server waits for the connection from the client side. Then here the client sends the request of passive. Okay, so instead of the active, the client sends the request here, the packet of passive. Or basically here, at first, basically the FTP client sends the request for the passive, which means that the FTP servers now know that the connection that FTP client wants to connect via passive mode. Okay, so instead of sending the request back on port from port number 20, from here, the FTP server waits for the connection from the client side. So here the client again sends the request from any random port, let's say any random port again, to any random port. So instead of connecting from any from the port number 20, the FTP server is connecting via random port. Okay, that is like the major difference. And in case of firewall, suppose the firewall is blocking the port number 20, let's say, which is let's say any packet. Here, the FTP client at first says that that the connection should be from passive mode. So that is why the FTP server waits for the connection from the client side. And if the connection is coming from the client side, the firewall will not block the reply as well, right? So here, that is why the FTP server is waiting for the connection from the FTP client, and then it is sending back the reply, which is not blocked by the firewall. And in the case of passive mode, if there's a passive mode, then here, like the connection initiates from the client side, which is like the for the connection, and second for the data channel, the FTP sends the request from port number 20. So here the port is 20, and it is sending via any source port, any like random destination port. But the connection has been originated from port number 20. Okay, that is for the data channel. But in case of passive mode, here FTP server is waiting for the connection to like initiate from the client side in case of firewall. And when the server is sending the reply, that should be not blocked by the firewall here. That is like the case in the passive mode. That is what I'm saying, that the FTP server waits for the connection. Okay, for from the client side. Okay, and if and that is like here FTP client is like FTP port is also random, and like FTP like data FTP port is also random in case of data channel. Okay, and for the connection or in if for the connection making and for this data channel, both like different TCP connection has to be established. That I will show you the file transfer. Okay, so is this clear in the difference?
Yeah, it's pretty clear now. Thank you.
Okay, so let me show you the file as well. Second. So here you can see here. First one we have, let's filter on the list. So FTP, simple. Okay. So first packet is this one, and that is source IP is this one. No. Think. Yeah. So first this one is my system IP, means this one is FTP client. So let's mark it FTP client. FTP client, and this one is my FTP server. Now my FTP client initiates the connection from its own side from the random port, which is 60592, to FTP port number 21, which is sync packet, right? For the connection or like for establish like sending the request for the connection establishment. Then my FTP service replying with a SYNAC packet from port number 21 to 60592 with the same port number, which is random port number from the of the or it is a local port of that FTP client. And then FTP client from its own local port sending the packet on FTP port number 21. That is like the acknowledgement packet, which is here we can say it is here the connection established from random port to port number 21. Same as here, it is like it is also random port. For the data channel, it is also the random port. Okay, and here you can see now that there's a like the verification. So my server FTP service sending the verification, like the first it is sending that your server is ready to respond. Okay, which is like it is sending the FTP version. And then here you can see we are getting we want to like connect via authentication method. So it is asking for the please login with username and password. Okay, and here we are like we are like sending the request like username and password. right? And here we are getting a response that login successful from that server side. And the username is user anonymous and password is anonymous @example.com. Okay, now here my FTP client is sending the request like some like system connection request, like the commands, like the basic command first, what kind of system you are running, and then here we are getting the response that Unix type. Okay, and here we are getting like sharing some more commands like for information gathering. Okay, for the future list, etc. Now the main thing here is look at here. Here we are like changing the current working directory to this directory, that is root directory. And here directory successfully changed. And then here we are like sending the pwd command, which is print working directory. This one is like the current working directory now. Okay. And here you see here, after the connection, we are sending the passive request from the FTP client. Okay, that we want to connect via FTP passive mode. And here you can see the server sending, okay, entering passive mode. And here in this bottom down, you can see entering passive mode. And the port which the server wants to connect with, which is like 26532. Okay, 26532. And here you can see FTP client is sending the port like the command that is from the source port is 60592 because it is a command request. Okay, and now here you can see here we are connected through passive up to here. Now why here we are like transferring from the same port number, because list is a command channel request. Okay, that is why we are using the same port. Now for response, FTP client sends the request that I want the list of like the files and directories in your current working directory. Now this one, the reply is from the data channel, and that is why the connection is like again established. And here you can see FTP client is sending the request on port number 26532. Okay, that is the port number which is using in the passive mode. So instead of sending the request on that port number 20, which is for used for the data channel, here we are using a random port. Okay, that is 60595. That is like the simple random port from the source side, but the destination side is also random, which is 26532. And why this is random? Because we are using the passive mode as sent by the client. Okay, as you can see here, the client here, in case of firewall, the client sending the passive mode, the passive packet request. Okay, and here you can see on port number 21. Then the FTP server wants to connect on port number 26 here, 26532. This one. Okay, look here. And then here we are sending the request for the to list the files and directories, and that is the command request. That is why it is like transferring via that same port, which is port number 21. Now we want a reply in terms of in terms of a list. So that is why that is the data actually. Okay, so that is why we are like connecting, like we are like establishing a connection on different port number, which is 60595. That is like that source port, and 26532. That is a destination port. Okay, that is random one because we are selecting passive. If that is active, then we will send it up like we are getting the response from the 20 port. Okay, which is like the default port for the data transfer. But in this case, we are requesting for the passive mode, which is here the FTP clients initiates the data channel again. Okay, and that is why we have the connection establishment process again, since in egg packet, which is like initiates from the random port to random port. Okay, up to here we are like here the connection has been established for the data transfer. And when you see here, here comes the list. Okay, and when you right click on here, follow TCP stream, and when you put it on, and here you can see this one is the list of all your like files and directories in the current working directory. Okay, like here we have 100 GB file, so 1000 GB dot zip. It is like zip file, or like random zip file, which is like the just test files. Okay, And then after this, then after the connection, we are requesting for this file, which is retrieve 10 MB.zip file. Okay. And then here we are like, you can see here transfer completed. And when you see the FTP data, just like here, and this one, these packets are of FTP data, which is of file transfer. And you can see the port number, which is like 29022, and that like the destination port is also random, which is for the FTP data. And here you can see like lots of packets of FTP data up to here. Okay. And here you can see the connection has been again orientated, like established in here passive mode on port number. Um, that is this one on port number 29022. That is why we are lots of packet of transferring. See, 29022 is like the new port for the data transfer. Okay, so here the client is sending the request again for like the client is initiating a data channel as well in the passive mode. Okay, so it is sending the passive request here, and then server is sending the port number to connect with. And here you can see FTP client is initiating, and here you can see the source port is also random, and that the destination port, which is like the FTP's uh, destination port, is also random, which is in case of passive mode. And why it is random? Because of the passive mode. And here FTP client is like initiating the connection. But in case of the active mode, if it is a active mode, then the FTP server sends the data channel request from its own side. Okay, so that is like the main difference. And here you can see we have lots of packet of. Now here we have the data transfer packet, that is FTP data. And you can see here the source port is 29022, which one is like from where the like the connection has been established, and source port is like the FTP client port is 606.117, which is same here. So 606.17 is a random port of FTP client, and 29022 is like the random port of FTP server. Okay, and why the firewall will not block it? Because FTP client is initiating the connection from its own side. Okay, to FTP server. Then FTP server sends the connection request back. Okay, so in this case, FTP server waits for the connection to establish from the client side in case of passive mode, so that firewall will not block any kind of response packet from server to client. Is it clear this much? Any doubt in the FTP
No doubt.
analysis? Okay,
It's fine, ma'am.
okay. So do you want to ask something? Any query, any confusion in this?
No. It's fine. Now everything is clear.
Okay. So now here you can see we have like lots of FTP data packets because of that 10 MB.zip file. At last you can see we have a like finish packets for terminating the connection. Okay, finish packet for like terminating the connection. So this is all about FTP. Okay. So I have shared you this file. You can find on your mail. Okay. If you want to analyze FTP PCAP file. Now we can move to TCP. 1 second. Do you want this file, this paint file?
Yes, ma'am. It will be helpful. Yeah.
So let me save it. So before moving to TCP, uh, there's one more feature of Wireshark that I have to tell. That is here. Let me open it. One second. See, let me start the capture. So here you can see we have lots of UDP buckets. And here, if you select here and click on here, so in this IP layer, you can see here in this destination address, which is like the Zoom IP, here you can see some more information. That is the server information of that or the location of that destination ID, which is Mumbai, India. Okay, and here you can see source or destination city, etc. So here you can see this information because of that database. Okay, so here that Wireshark is giving the additional information of the location of the IP, like where the server is located of that particular IP, or from where the connection is, the data or the packets are coming from. That is here you can see the country, city, ASN number, etc. And here you can see some more information, that is latitude and longitude information as well. So how you can see this information? For this information, you have to add something uh, to database. So here click on edit preferences. From here click on name resolution, and from here you can see maximize database directories. So here you have to add the directories of that locations. So from where you can download, you can visit on Chrome, and from here you can search for maximize geolocation database, or just maximize database. Okay, from here you can click on here maximize database. So for this you have to create your ID here. Okay, you have to log in via your ID. Okay, so create your ID. After creating ID, you can download. You have to download three files. And what kind of file? Let me show you. These files, which is GeoLite, ASN number, city, and country. Okay, so after creating your ID, you have an option of downloading these three files for free. After this three files, you have to keep these three files in a single folder. Okay, name anything what you want, that is database. Okay, so you have to keep these three files on the same single directory. After keeping these three files in a single directory, you can add it via here. You can click on name resolution, preferences, names resolution, and click on maximize database directory. Click on edit and click on plus here and add your location where and click on browse and move to your location where your directories are located. So in my case, it is inside downloads and database, and click on select folder. From there, that folder should be added. Okay. And from that, click on OK and click on OK. And then you can see you have these information. Okay. That is like the extra information. For that, you have to restart your Wireshark. After restarting, now you can able to see these information. Let me remove these first. Okay. Let me show you. From name resolution, next file. Okay, so here, let me remove this. Click on OK, click on OK. Okay, so when you see from here, now you will see in the IP layer, let me restart the Wireshark content. So in the IP layer, you can see we don't have any much information. Like you can see the source address, which is source IP, and then destination address, which is destination IP, and rest, and that's it. We don't have any like location information, like where the connection is arising from, like the country, the city, etc. That is not displayed by Wireshark because that is not in the database of the Wireshark. So that's why we have to edit references, and then we have to add from here maximum database and directories. Click on plus, move to that location where your database, where your three files are located inside the same folder. Select and click on OK and click on OK now. Okay, and then here you can see we have to restart the Wireshark. Okay, then let's open it. This one. And here you can see in this IP layer, you can see information like source GeoIP. Okay, source GeoIP city is Mumbai, country India, etc. information. Okay, same as you can see the destination information as well. So that is like this is the future of Wireshark to know the location of a particular IP from the Wireshark itself. Otherwise, you have to add this IP on the geo map to find the location. For example, here we have one more application for that. We can search for IP stack. Okay, this one. So IP stack will show you your location, like where your current location is. Okay, on the basis of IP. And as well as it will show you the latitude and longitude. So whenever you're getting the request, like whenever you're getting any packet information, like source IP is this one. So suppose you want to find out your source IP or your destination IP, then you can put it here. So it will also show you the same information that Wireshark is showing. So but here we have added this maximind feature, here like database feature, so that the Wireshark is displaying everything, each and every information, like the country information, city information here only. Okay, like here you can see the latitude information, longitude information, etc. from here. Okay, this one is like the feature of Wireshark. Is it clear this much?
Yes, ma'am. It's clear.
Okay. Then we can move to TCP. So first in this TCP, we will identify the three-way handshake and then we will identify the TLS handshake. So there's a difference in the TCP handshake and TLS handshake. So TCP is like the simple one, which is TCP is a connection oriented protocol, which is like before the actual transfer of data, TCP like established the connection. Okay, so here you can see we have three packets for that, SYN, SYNAC, and ACK packet. SYN for the data establishment. So here the client is sending the same packet that I want to like establish a connection. And then he has a service sending, okay, the connection has been established, so your connection request has been accepted. And here we are getting the acknowledgement packet because the service telling to the client your previous packet has been received by me. Same as the client is sending the ACK packet again and saying that your previous packet has been accepted or like by me. Okay. So we can like simply analyze this. It is like way more simple. So we can select any file. So this one is like TCP, simple connection without any security. Okay, that is TCP three-way handshake, which is simple three-way handshake, which is like without any encryption level or without any security. Okay, that is like simple connection. But in case of TLS connection, we are connecting TCP with security. So first in TLS connection, so in TLS connection, first we have three-way handshake packets. Second, we have some connection like cipher packets, like which encryption level we have to use in while transferring the data. For example, TCP three-way handshake is for HTTP, and for HTTPS we have this one. Okay. For example, let me show you the file for that. And here you can see, let's TCP. So TCP connection is like that is simple. You can see the SYN, SYNAC, and ACK packet, which is like here you can see 443 is for HTTPS. So that is why here you can see the simple TCP packet, three-way handshake. Now for the TLS, let me show you the figure for that. TLS handshake. Here you can see. Here, the client is sending the SYNAC packet, first, sorry, SYN, and then SYNAC, and then ECK. So this is like the basic connection, TCP three-way connection. Now, after this connection, we are sending the client hello packet for like for making the connection like encrypted or for the secure connection. Then server sending the server hello certification, and then it is sending the certification like server hello has been done, like the connection like for like the secure like the connection for it is like we can here it is like saying that we want to connect through a we want the we can say a secure connection. Okay, and then the client is sending the client C key exchange package, which is like it is sending the like the encryption packet, like which encryption we have to use and other certifications for that. And then the service exchanging that cipher spec for that. So basically they are sending here we are like sending the packet for for that secure connection. So here we are like sending the exchanging the encryption packet, like which encryption level to use or what kind of encryption to use in these packets. And after like exchanging of these packets, the is like that TLS handshake or TLS communication has been established. That is like the basic difference in TCP and TLS, which is like TCP is like without security and TLS is like with security. And here you can see that the server source IP sending the client hello. And here you can see we have a server hello somewhere here. And here you can see in the TLS we have additional layer of security which is TLS. And here you can see client hello packet. Okay, this one. And we have some other information. Okay, like what version of TLS that is of SSL is using. Okay, whenever you're using SSL certification, we do have the TLS communication. Okay, you can see cipher suits as well as etc. And if you want to filter on the basis of client hello packets, like if you want to check how many clients hello packets are there inside my network, then you can simply like filter on this one. Handshake type, applies filter selected. And here you can see we have only client hello packets. Okay, in this network. Like how many packets of are of client hello. And when you type 2 here, you can see the server hello packets. Okay. And here you can see the server hello from the YouTube side, which runs on HTTPS. That is why we are like making the connection coming like secured. And you can see HTTP3, which is like which we will discuss in the HTTP. Basically, HTTP3 works on the quick protocol. This one, and quick protocol basically works on the UDP. So that we will discuss. Okay. On TCP. And here you can see after the client hello and server hello, we are sending that after like change cyberspec, like which kind of encryption to use. Okay, which is we are exchanging via Shodan. Shodan runs on HTTPS. That is why we are like connecting through TLS. Okay, and here you can see then we are getting the response somewhere here. Okay, as we have like lots of packet. That is why from Shodan. So client key and then key exchange. And then here you can see we have the packet which is change cipher spec, which is encryption handshake initiated message. Okay, like what kind of encryption you are using while transferring the data, as well as other informations. And that is like how the TLS handshake like generated. Okay, after that we have a application data that is like the actual data. So this is like the basic difference. In TCP, we are like sending three packets for the connection, that is SYN, SYNAC, and ACK. But in case of TLS, we are sending some more packets for the for securing the like communication or for the securing the that communication channel. Okay, by sending the like client hello, server hello, and some of the encryption packets. Okay, that is like the SYN, SYNAC. And while finishing the packet in terms of that. TCP, if someone wants to terminate the session, then here you can see the sender is sending the FINAC packet, FIN packet, and the receiver, which is like anything, your server or any other client. So it is like sending the egg packet and then fin packet. And this is so finish an egg packet, finish for terminating the connection, we exchange four packets. Fin and egg packet. As you can see here, I think here you can see fin packet, fin egg packet, egg packet from 5 to 1 minute. So here we have some packet. Some egg. I don't know. So let's filter on the basis of this packet, which is IP is IP.8 52.13.p. One. Oh, why do we put single packet? Okay, let's find fin packet. Here, this Finec, let's filter on this Finec packet. Okay, in the TCP, in this flex Finec packet, right click, apply as filter or prepare as filter first, selected, enter. So this will show you the Finec packet of the communication. So let's find it of YouTube. So let's apply filter. IP.ADR equal 142. I think there's a problem while applying the filters. IP. Let me restart this file. So let's apply that fin flag, right click and apply filter select. So here you can see we have like lots of Finec packet. Let's catch any one communication for checking that fin packet in sequence. This YouTube. Okay, so right click on this IP. Source IP is this one. Destination IP selected. That is of IP dot. Yeah. So here you can see we are like finish packet. Like it is like a four-way communication. Like first we are sending the FINEC packet, and then that the server is replying with the egg packet that your previous packet has been received. And then here we are receiving that request again that here we are that server is sending the fin packet again. Okay, so the server also wants to terminate the connection, and then here we are sending the egg packet again, egg and egg server, and then client and then server. Basically, in most of the cases, it is like the four-way process: fin egg, and then fin egg packet. Okay, in some of cases we are getting the egg packet like in extras. That is like the full process. Okay, is it clear this much? How you can analyze TCP, handshake,
Yeah,
TLS
yeah,
handshake, and that fin packet handshake.
yeah.
So, so basically, the next thing is that is how we can next of how we can like basically analyze the HTTP and TCP traffic. Okay, so for that we will continue tomorrow. Okay, because today I have some meeting, so I have to attend that. Okay, for the FTP and TCP, that is like a long topic, so that we will complete tomorrow. Okay, so basically, few topics are left with FTP and like FTP, TCP, and DNS, SMTP. These like some few topics are left that we will discuss tomorrow. Okay, so tomorrow
Okay,
we will continue with 2 hour classes. Okay, is that
okay.
fine?
Yeah, yeah, fine.
Okay, so like in upcoming 3 days, we will continue with 2 hour classes so that we can complete the syllabus within this week. Okay,
Okay, okay, no issues. Thank you.
okay.
Mhm.
So I will share this file. Okay,
Okay, ma'am.
and if you have
Thank
any
you.
doubt, you can just ping me on WhatsApp.
Sure.